All right, for this week's exercise, we're going to look at education and taxes and support for education. This actually was recently in the paper with the ISER report about we need to pay teachers more money in order to keep teachers up here in Alaska. We're going to look specifically within the Anchorage municipality because they do have a property appraisal database readily available. And so we're going to look at how much financial support does a high school student get from the taxes collected by the municipality of Anchorage in student per dollars per student. And then instead of having everyone pay to support the schools, what if someone proposed a policy where only households that have children, 18 years and under, pay support for the schools? So what would that look like? And how much would households have to pay in order to provide the same level of funding as a property tax-based system? And so to do this exercise, we are going to need data from the MOA, the tax districts, and the property appraisal databases. We also are going to go back to this IPUMS GIS data portal. You saw it in an earlier exercise. We're actually going to go through and download the data because there has been some issues in downloading the data and using it. And so lots of professors, including some of mine, just like to give you the GIS data, and then you go to try to do research on your own, and you can't figure out how to get the GIS data. So I decided, even though it's going to take some time, we're going to go through downloading the data and getting it into a GIS format. And so one word of warning is you do need to create an account for this IPUMS GIS data portal because they will send you an email when it is ready to be downloaded. So be sure to do that. And so how is school funding calculated within the Anchorage municipality? On your tax bill, there's an Anchorage School District mill rate. And in some cases, the mill rate can vary spatially throughout the municipality. Well, this rate is multiplied by your property value and then divided by 1,000. So that gives you what your payment is to support schools within the Anchorage School District. And so what I tried to do is put together a flow chart of kind of the processes that are going to occur. So now that you've been introduced to Model Builder, you'll be, kind of more familiar with something that looks like this as a way to put down kind of your steps in your flow for your analysis. So here we have the property appraisal database and we have the school district boundaries. And so you have to figure out which property goes to which school district, and so assign the school district to the property. And then you have to figure out, okay, what is the mill rate for these properties? So you got to assign a mill rate to the property. And then you use the field calculator and kind of this formula that we have up here to figure out how much each property is going to pay based on their mill rate and their appraised property value. And then, because you know which properties go to which school, you can summarize the payment that is going to go to each school. We also have enrollment numbers for the school, so you'll be able to then figure out how much, dollars per student we have for support for students here in the Anchorage municipality. And so, first things off, I'm going to move this down to my other screen. And so we can focus on ArcGIS up here. Back up and get it going. That's going. I believe I need to also provide you guys with enrollment data. So school enrollment. This is what you will need in your student data folder. I will also put it in the test one that I'm doing here. Don't need it to create another folder within a folder. Okay. All right, so just map. Oh my goodness, so squishy. Ha, ha, ha. Oh, and I can't even change the size of that. That's very weird. Okay, we'll call this education. This isn't a sign of problems. And we'll save it somewhere. So I'm going to save it in my temp folder. Okay. Okay. So I'm going to add some data. So go to your folder that you downloaded. And add in the high school points and the high school boundaries. Boundaries and high schools. Okay, I noticed when this is added, it's not really in the projection that I like, so I'm going to just change the projection so it's projection I'm happy with. So you can go over to map and you can go to properties and you can go to coordinate systems, and I'm going to change this to Alaska equal hours just so it looks a little bit better. There we go. Didn't really change. Maybe it's already in it, but before it was not. Okay. All right. So now we're going to add the property appraisal database. So property information. Okay. And I'm going to change this high school boundaries so that it is something I can see through. And I'm going to move it to the top. Okay. All right. So I'm going to zoom in here. I can change mine, I guess, to be blue since that's what I have in the guide. Okay. There we go. All right, so here we go. I see this. I'm actually also going to put the labels on for the high school boundaries for the schools. There we go. So I'm going to make this actually a little bit bigger so it stands out. Okay, so we see here's the boundary for the parcels that go to service, the ones that go to West Anchorage, Diamond, and so forth. So we can see our parcels and the school district. So we need to assign a property to a school district. Okay. So in this case, since we want a parcel to have one school district, we actually can use a spatial join. So go to analysis, toolbox. It's overlay. Yeah. Spatial join. All right, so we want the school boundaries to go to the parcels. So our target is going to be our parcels, our property information. The join features are going to be the school boundaries. Okay. And I'm actually going to choose, let's see, there should be one where it's largest overlap. Where is it? Oh, there it is. So, we could have a situation where maybe a parcel goes over two different school districts. We're going to say that wherever the largest area occurs, that's the school district that that parcel belongs to. And this is a one-to-one join. And we're going to rename our new file here, property, high schools. You can just save it in the default geodatabase that comes with the package that you made, and it's a one-to-one, and hit run. All right, so it is done. The spatial join is complete. So let's open it up and take a look at it. I do ask you a question about, when you're done with any GIS property, process, you should always think about how could it have gone wrong and failed, and what are ways in which I can check to make sure that the GIS process worked. And so I do have a question about what are the 2 ways in which this tool could not perform properly, or wouldn't fails. So one of the ways, that I visualize to check to make sure that my parcels were in fact assigned to a high school is I use the symbology. So I'm moving the school boundaries again up to the top. Now I'm going to use the symbology by that new field that should be there that represents the schools. And so if it did work properly, each of these parcels should be assigned a color that all these should be a west color. All of these should be a diamond color that corresponds to their schools. So we'll go to the end here. So it always throws it at the end. And go to name. Oh, it scared me there for a moment. Yes. And so we see that for the most part it worked. It is interesting that these parcels here are assigned to service instead of East High School. Looking at this. So I'm not entirely happy with that, because I would think that these would be assigned to East rather than service. So why don't we try to run our tool again, and this time let's change it to where their centroids are. So to rerun a tool, we can go up to history. We see our spatial join here, double click on it. And then instead of largest overlap, I'm going to say their centroids are in, have their center in. And then I'm going to hit run again and see if that produces results I'm happier with. Alrighty. I'm going to do the same thing. Symbology. That looks a bit more like what I want to see. So I like that result better. So again, it's always just going in there and visualizing your results and making sure you're getting what you think you should be getting. And this one is a little bit odd here. Select, see what this parcel is. This parcel is part of a really big parcel here, so that's why its centroid is probably off over in here. So we're good. Okay. So I do have a question about how many parcels did not get assigned a school district. So I'd like you to take a look at that, look at the attribute table and figure that out. All right, so if you weren't able to get it, you use select by attributes, and what you're looking for is when the name of the school is equal to a null. So there are going to be, you can kind of see some school properties, or some, sorry, properties that are not assigned to a school. We can live with that for now. That's all right. So, all right. Now we need to add the tax shapefile. So we'll go in the tax districts. Okay, so I'm going to turn off the high school boundaries. Here you see tax districts for the Anchorage municipality. Let's take a look at the attribute table and see where the school information is. So police, fire, parks, roads. Okay, so we have this one called school underscore CR. This is the, let's say, mill rate for the schools. So this is what we're going to be multiplying by the property value and then dividing by 1,000. And so use the symbology. I'm going to say use the symbology to see how the mill rate might vary within the Anchorage School District area. So use the graduated colors, since this is probably a number field. And we'll go down to school. And, there are only actually 2. So basically everyone pays the same mill rate for the schools. So 7.63 times your property tax value divided by 1,000. Obviously, J-Bear here, the military, they are the big area that is excluded from having to pay the municipality for schools. So it's kind of nice. It's not a lot of variation. And so we could do a spatial join to get this mill rate information into our property, our high school property database, but we really don't need to. What we could do is we could do a select by location and select all the parcels that occur within this area. That's 7.3. So, but an easier way to do it actually would probably be to first select the task districts where it's 0. So select by attribute and school is equal, we know it's 0, hit apply. I don't know why it turned it into a Python script, but okay. 0. Okay. And so it did select the task districts up here where it's 0. So now we could do like a select by location. And so we'll select all of the parcels that are within this selected location. So select by location. And the selecting features is actually going to be our task districts, and it's going to be the 2 areas we have highlighted. This is actually going to be our high school properties. And the relationship, we could say have their centroid in, have their center in, and hit OK. All right, so we'll turn this task districts off. And you can see that it did select the areas that occur within that. So let's open up our high school property. And instead of doing like some spatial join that creates another table, we're just going to add a field. And this is where we're going to transfer our school tax rate to. So let's see. I'm just trying to see if I call it something special here. I call it mill rate, so we'll call it mill rate, M-I-L-L-R-A-T. Mill rate. Make it a double. And hit save. And I believe I do ask you how many properties pay 0 for their mill rate, so that might be one of my questions that I ask. So go here, and we'll use the field calculator for mill rate, and it's going to be a 0. Not sure why it's always showing up kind of tiny. All right, 0. Okay. Now we can go switch the selection, and everything else gets the rate of 7.63. So switch. And now we can easily just do the calculator. 7.63. All right, so now we have kind of our mill rate for our schools attached to each of the properties. Okay. So I'm going to clear everything. All right, so looking at our property high school database, the next step in our process is we need to figure out how much they're paying into the schools. So looking across here, I see some values here. Building value, land value, taxable value. Here we go. Here's the column that we want. So this taxable value is the amount of money that can be taxed. And so this is the one we multiply by the mill rate and divide by 1,000. So let's go back to the end and do a field calculate. Oh, first we got to add the field. Okay. And we'll call it ASD funds. So ASD funds, ASD funds. We'll make it a double and hit save. Okay. Now we can go to the end and use our field calculator. Alright, so we find our taxable value. Times our mill rate divided by 1,000. Okay. So this will tell us how much each property owner pays in. Of course, a property owner, if you have multiple properties, you'd have to sum them up, but basically for each property, this is what is owed. And you might get an error because maybe some of the property appraisals are null. In this case, it did not give me an error, which is interesting. I'm just going to come over here, taxable value. I'm going to sort this to take a look at it. Ha! Someone has a negative taxable value. Okay, I guess maybe they're getting money back in to the system. Okay. And some others have 0. This again, looking at your data is very important. I am not believing that this person would get money back in. So I am actually going to manually change this ASD funds to 0 because it should not be a negative value. Okay, so again, always look at your data. And now I'm going to go back up to edit because we actually made a hard edit to our database. So this is when we have to actually hit save. If we use the field calculator, you don't have to hit save. But if you go in here and you do hard edits, you've got to hit save. Okay. All right. So clear everything there. Okay. All right. So now we want to summarize how much funds, are going to each of the schools. So we do have our school here. And so this is, simply a summarize. So summarize. And we're going to sum up by the school that last column that we made. Okay. And save it in your default geodatabase, but we're going to give it a name. And we're going to call it high school funds. Okay. And hit OK. And now let's take a look at this. And let's see, let's sort. All right. You can see how much money each of the high schools gets. I ask you which one gets the most, which one gets the least. So, all right, there is quite a bit of variation here, but maybe it's because some of these high schools have more students than others. More parcels equals more students. So maybe it's fair that one gets more than the other. So now we're going to figure out kind of the per capita, how much each student gets. And so I have in your tutorial to go to a website that collects data about schools. And so there's the Alaska Department of Education and Early Development. And you can go to statistics and reports. And let's see, enrollment totals. And you can go to enrollment total for all Alaska schools. And we could select this most recent year. All right. And I believe I have downloaded this to your folder. So I'm just going to open up your folder here and see if it is indeed there. No, it is not. So I'm going to save it to a temporary spot. Okay. Open it up. Okay. And so here's the enrollment totals for the schools in the state. So we're primarily focused on kind of this total. So we got to find the schools that we're interested in. So what I would do is I would recommend putting on a filter. Okay. And so I'm gonna see if I can do some fancy window positioning here. I'm not sure if I can since I'm on a VPN. Okay, I can. All right, so we want Bartlett. Okay. We want Chugach. Okay. We want Diamond. East. Service. south, and west. All right. And so these are our enrollment numbers. Okay. So I'm going to go back to this high school funds database, and I'm going to add a column called funds, one called enrollment, which we're going to put these numbers in that database, and then we're going to create another column called funds per student, which will be a double, and then calculate this value. So I'm going to take this screen and make it like that. If I can, come on, grab. There we go. This is being annoying, so I'll get that out of the way. And I'll get my numbers here back up. Okay. Getting annoying. I'll hide these. There we go. Okay. Come over here. Open this. Add a field. One called enrollment. Keep it along. One called funds per due. Per student. Make it a double. Hit save. Okay. Okay. And I'm going to bring up my Excel file. I don't think it'll show so on your screen, so I'll have to have it down here on my other screen. So I always have two computer screens. Ha ha ha. And now I'm just going to sort these by name, since that's the order my Excel file is in, by their name. So Bartlett. Okay. Uh-oh. We're missing one. Let me see. Bartlett, Chugach, Diamond, Eagle River, East. I forgot all about East. How could I forget East? The most diverse. East. Oh, the one thing about East is it's Betty Davis. So I forgot to mention that. So when you look at it, it's actually not East officially, but it is the Betty Davis East Anchorage High School. So that's the one that you will be looking for. All right, so I need to change East here. East is actually pretty big. 748. Okay. And thus that makes service South Anchorage is 13. All right, and 1764. Okay. All right. So just double checking my numbers here. Okay. I'm going to go up and hit save. Okay. And now we can calculate the funds per student. The field calculate. So ASD funds divided by the number of students. Okay. And yes, you will get an error because one of the values was null. And ArcGIS doesn't like that. See if I can get this to go to the whole screen again. All right, so that is what I get per student. So the support is $44,000 for a single student at West High, all the way down to $14,000 for a student at Eagle River. So quite the disparity there. All right, so there we have our result. That's pretty shocking. $44,000 per student at West High. I'm just kind of curious, you know, with this property information, what these taxable values look like. Actually, we could look at the payment. So we can go to graduated colors, and we can go down to our ASD, our ASD funds. Actually, I chose the wrong one. Sorry about that. High school, and go to symbology. That's where we have our ASD funds. I'm just kind of curious. Only gave us 2 categories. But, I mean, we can kind of look at where the real high ones are here. And you can see there are a number of them here in West Anchorage. You could go back to the symbology and just look at these top 2. Make this blank, no color. This no color. Apply. And you can see now kind of where the parcels are that are really paying in to the school occur. A lot out by the airport. So curious kind of who pays that, if the FAA pays that. This is where working with, you know, the people who develop these policies and know this data, it would be very, very helpful, like in our analysis. Is it appropriate to include, you know, this land out by the airport or not? Because that will drastically change the per capita calculations that we have. And Eagle River has nothing that comes that close to being up in the upper part, and Chugach School has 2. So an interesting result. Okay. All right. So now that we've looked at how much per capita the students cost within Anchorage, we're going to turn our attention to trying to address the question of if we change this to only households that have children pay. So you're going to need to go to this data to nhgis.org and create an account. So I'm going to log in here. All right, so we're going to go through and we're going to find the data, and what we're interested in is finding households that have children. So geographic levels. We're actually going to do the block group because the block is too small. So the block group is a group of blocks. So it's 1 up in size from the block group. Check the box next to it, hit submit. And go to topics. And we want to go down and we want children in households. Check that. And hit submit. Now let's go to years. The census does not collect information on this. Don't believe this little census thing. So go to the 5 to 10 5-year ranges. So this is ACS data. So we're going to want to remember what it is we're choosing. 2017 to 2021 5-year average of ACS data. Hit submit. And you can click on this data sets, but basically it's going to tell you, okay, this is the only option that you have is this ACS data, the American Community Survey data. So if you want to check it, sure, it's the only option we have. Okay, all right. You'll see that we have some tables here of different data that meet our criteria. The one that we actually want to check is this household by type. And now we will see that we have one source table in our cart. You can go to this GIS files tab here, and I mean, you could expand 2021, or sorry, check on it, and now you have one GIS file there. So we're going to supposedly have one data file and one GIS file, and then you can hit continue, and then continue. And even if you do select GIS files, it still will ask you at the end and tell you no geographic extents included. So you're going to have to click on this, and you're going to have to go to Alaska and then hit submit. And so now you will download a GIS file with your data file. So it's very important to make sure that you get both. And as you continue on in this, you might have other extracts. So it's a good habit to give a name to it. So households by type is what we chose, and it's ACS data. It was 5-year, 2017 to 2021. You put BG for block group, and then hit submit. And so it will come up as queued. You can see I recently did this query, and here it is. And so you'll get tables and a GIS file. So when these pop up, go ahead and download them. And save them to your folder. So I usually, in my education here, I created a folder that's like IPUMS. And here's where you're going to have a download that's called the CSV.zip, and you're going to have a download that's called 44, because that's the number of my queries. Yours might be 0001, and a shapefile. So this is your GIS file, and this is your actual raw data. Okay, so when you click on them and unzip them, it's going to give you another folder, but you're going to get a CSV file and you're going to get a code group. So let's just start with the data first. And so I've already unzipped it, and what you're going to get is this CSV and this code book. So open up your code book, and it's just going to open up with Notepad. And this will tell you, okay, this is what you downloaded, this is your data, geographic area, but it'll also tell you what are the columns and what do they mean. And all of the data comes with these columns. This is the most important, your GIS join. So this is the field that matches this text, data with the GIS data. And then we get down here, and okay, this is our actual ACS data. So we have the total number of households, the total married coupled households, with children, without children. And they, in this database, have decided to divide it up into 4 different household types. So in order to get the total number of households with children, we're going to need to add up this field, this field, this field. So we're going to need to add up 4 fields. I say this is easier and quicker to do outside of ArcGIS. So that is what we are going to do. And so we can minimize this, and we can double click on the CSV file and open it. Okay, and so here's where you need to remember the columns that we wanted. So if we go to the end, we can see we get into our data here. So using this, we want one column that's called this one. The easy way to do it is you could copy and you can go back to your Excel file and you can do a Control F for find, paste it in there and say find next, unhighlight what I've got going here. Did it go to it? There we go. Find next. Okay, so here we found this column. I would recommend highlighting your column some obnoxious color. So we found that one. All right, go back to here. The next one that we want is this one, this column. Copy, go back to your Excel, go to the find here, find next. Okay, this column, obnoxious color. I don't know what I did. Color, there we go. Go back to Notepad. Now this one is the one that we want. Copy, back here. So I don't have two of these open. Paste, click off, find next, this one, okay. Alright, and then one more column that we want, this one here. Okay, click off, and this column. Alright, so we are going to want to copy these 4 columns and our GIS join column. So I'm going to click at the top, hold down my control button, click at the top, click at the top, click at the top, then go all the way over to the front of the database. Keep holding down your control button, click at the top, then keep the control button down and hit the C button for copy. Start a new file. And paste. All right. So these are the 4 columns we need to add up to get the total number of households that have children. All right. And I'm going to call this HH with kids. All right, and see how I did the sum? Go to the corner here, and I can double click and it'll fill all the way down. If I hit the control, I can easily go up and down to the bottom of my database. So control down, I can see it's filled all the way in. Control up, I go to the top. CSV file will not save your formula, so you must copy this and hard write it. So paste values only. And therefore you got rid of the formula and you actually have the values. So now we are ready to save this, and we need to save it as a CSV file because ArcGIS does not like Excel files. And navigate to your folder. And I am going to call it something ridiculously long, but something that will let me know what exactly it is. So I'm going to call it number of households with children under 18 ACS 2017 underscore 2021. Okay, I'm not going to save it again because I've already saved it, but that's what you should save it as. So there. And then I'm just going to close this down. Close down the original one. We don't really need to save any of our changes. Close down the text file. Okay. And now I can go back to ArcGIS. And now I can add in that text file. Okay. Now go back to your folder. And wherever you downloaded your iPooms data, now you can extract the shape file, and you should get folder within a folder within a folder, and cancel. Oh, whoops. No, I did not want to do that. You should get Alaska underscore block group underscore 2021. So I want you to add that next to your project. Okay. So there you go. Put the high school boundaries up on top. All right, now we have added the ACS block group information. Here you can see it on the screen, and I put the high school boundaries up on the top, and you can see, like, for example, this high school boundary intersects right in the middle of this block group. So as I mentioned, the challenge is how do you take this ACS data and partition it so that our neighborhoods, our parcels that are within this area get information from this census block, and the parcels, say over here, get this information from this census block. So we're going to go through an exercise as far as how to do that. Okay. All right. The shapefile that you added, if you didn't notice, is for the entire state of Alaska, and we don't need that. And so I'm going to come over here and do a definition query and just show the Anchorage area. So it's actually this county code, and Anchorage is 20. One thing too is, if you're going to be using queries a lot, you can just check them on and off here. Like now that query is not active, instead of totally deleting a query, because maybe you want to come back to it and you want to make that query active again, you can check on and off this green button here and then hit OK. If it's green, it's active. If it's not green, it's not on. So there we go. Now we are only showing the Anchorage area. Okay. So as I mentioned, this is just spatial data. Open it up. It will have this GIS join column, and we have our non-spatial data information, which is the number of households with children for each of these GIS polygons. So this GIS join is a common field here. Okay. So what I would do is I would add a field to your GIS data, to this block group, and call it households with kids. Actually, I already have one on there, so let me discard. Actually, I'm just gonna, in my purposes, I'm gonna call it 2 because I already have one on there. But for your purposes, just go ahead and just call it household with kids, and I'm gonna call it along, and hit save. Alrighty, that's a pain in the butt. Okay, so discard that for now. This happens if you have other projects open that might be using this data, which it looks like I do, so I'm going to close this down. And that's shutting down, and I have this one open. So I was doing some exploration here. I don't want to save that. Alright, now with these other projects, I'm going to try that again. Okay, close this. Now do the join. So join your non-spatial data to your spatial data. So go up to table. Join. And this should be your number of children. The GIS join is your common field. Okay. All right, and use the field calculator at the end here to update your data. Grab that household with kids information. You're joined. Okay. Okay. All right. So one of the issues, that we're going to run into, because this is kind of area based, is what do you do with all of this block group stuff that is outside of the Anchorage School District? So, for example, what we're going to end up doing is this. Let's take, for example, this block group here. This maybe has, let's say, for example, 100 households in it. And so the way that we try to deal with the mismatch of boundaries is one can be an area-based approach. So in this case, if let's say 40% of this area occurs within this school district and 60% occurs out here within, no district or a different school district, 40 of the households with children would go here, and 60 of the households with children would go here. That works, but this creates a problem in that you're going to have 60 households with kids in this instance dropped off. And I suspect that there's very few people that live out on this part. Let me make this a different color here and clear so we can see it, because one of the assumptions is if you're just using the area and using that to figure out how to split up the households assigned to each of the block groups, then you're assuming that they're equally distributed. The people are equally distributed within the census block groups, and they're not. I mean, this is all mountains. So if there's 100 households, for example, in this block group, they're more than likely going to be all down here. And the school district boundaries, I'm confident, are drawn where people live. So in this instance, one of the ways that we can take care of this is just get rid of all of these block groups, the area outside of where people live. Okay? And so that way we can then, when we do our next step, we can say, okay, all 100 of those households are actually here and very well likely belong to the Chugach High School instead of out here in the mountains. Okay? So I'm going to give this back some color because this will help visualize what we're doing here. Okay. And so what we're going to do is we're going to erase the census block groups that occur outside of the school district boundaries. So what I want you to do is go to Add Data and go to your folder. And there should be a file that represents the area outside of the school district boundaries. Area outside high schools. So this is effectively representing the areas outside of the high school boundary. We are going to use this to erase the block group that occurs out here in these areas. So put this back down here. Oh gosh. Put this on the top here. All right. And so go up to Analysis and go up to Tools. Turn back on, pin it so it doesn't disappear on me. All right, and Extract. Oh, whoops, it's an overlay, erase. All right, so our input features are going to be our block group, and our erase features are going to be our areas outside the high school. Okay. All right, and I want you to just keep this in the GeoDatabase. And we're going to call it A underscore block group. I'm going to call it, I can spell erase. Ha ha ha. Okay, hit run. Okay. So I'm actually going to copy this name. And I'm going to name this one the exact same thing. Okay. And then I'm going to remove the original so we don't get it confused. All right. So now if I turn this off, turn off high school boundaries, you can see that now we have the block groups clipped. It is a little weird. You have some dangling going on here. These. And over here. What I might do is try the edit, modify, select. Let me see if I can select this. Now if I tried to erase that, it would erase all of this polygon here. And I don't really want it to do that, so I'm just going to hit clear, and I'm not going to mess with it at all. You know, if we were doing, you know, this analysis, I would, you know, figure out a way to get rid of these weird parts that didn't erase, but for now it's okay. I mean, the area in these, it's just little slivers, so it's all right. But we have our new block group boundaries, and so our block group boundary area has changed, because remember we said that we're going to try to do this by figuring out, I'm going to put the high school here up at the top. What we're going to do is we're going to assign based on what percent of this census block group falls within, say, the Bartlett High School, and what percent falls within the East High School in this example. So within this example, let's say we'll pretend like for this block group there was 100 households with kids. 75 of them would go to Bartlett High School, 25 of them would go to East High School. But we need to, in a GIS fashion, figure out, you know, what is the percent area within one school and within the other school. Okay? So that means first we need to recalculate the area for our census block groups, because remember we erased part of it, and so now we've changed the size of these groups. So I'll open up the attribute table, and I want you to add a field called area KM. I'm going to put a 2 after mine because I already have a field called area KM. You just call it area KM though, and you make it a double. Save. Go over and do the calculate geometry. Area, kilometers, coordinate system. Just pick what the block group is in. Okay, and hit OK. Okay, All right. So now we have our new area calculated. Okay, so now we're going to use something called the tabulate intersect. So the tabulate intersect is going to help us figure out how much area is within one high school versus the other high school. So just finding a good example here. Go back to our example over here. Say this guy. Okay. All right. So I'm going to close this down. Go up to analysis, tools, and it's actually in the analysis tool, statistics and tabulate intersect. Okay. All right. And so now our input zones are going to be our high school boundaries. And it's going to be the name of the high schools. Okay. And the input feature class is going to be our ACS data. Okay. And maybe we'll call this 8K block CK. That's our GRP. I call it. Let's call it tab intersect. Okay. Our class field here is going to be geo ID. Each of these has a geo ID. I check to make sure that they're unique, and so each of these has a unique geo ID. And we're going to sum up the area that we just recently recalculated. So this should give us a table that tells us how much of the area for each of these geo IDs falls within the high school boundaries. So how much falls within Bartlett boundary, how much falls within East High boundary. Okay. So the output units are actually, we want to set that to be square kilometers because our input is square kilometers. Okay. And then hit run. Yeah. So we'll open this up. Okay, so let me add on the geo IDs for this block group. So we'll go to label. Let's go to labeling and turn this into geo ID. Okay. All right. And I'm going to go here to the labeling properties. What is it under position? There's a place that I always forget where you can here reduce the font size so it should fit within the block groups. Let's see. Kind of works. Okay, so I can see that this is, it looks like 17023 is what this looks like to me. So I'm going to come in here and find 17. I'd buy it 17. Actually, it might be better to just do the select by attributes instead of trying to sort geo ID. Span this out. So 0 2 0 2 1 2 3 17023. To me, that's what this one right here looks like. And I'm going to hit apply. Okay, so zooming into right here. Again, this is just a way to double check our data. I'm going to look at these two that I've selected here. Okay. So this has 48.48 kilometers is within the Bartlett High School District, and 0.616 is within the East High School boundary. So if I pull up my just a calculator here and add those two up, so that would be 0.48 plus 0.16. That gives us a total of, originally there was 0.64 square kilometers. So if I divide 0.48 by 0.64, so divide this part of Bartlett, the whole thing, that gives me, well, roughly what we would expect, 75%. So I'm confident that this area is working the way that I want it to. 75% is within the Bartlett, and this little tiny corner here, 25% is within East High. One thing is that this percentage here does not reflect that. This does not say 75%, and this does not say 25%. This percentage is it's a weird calculation of, this is how much area this represents out of all 278 potential interactions. So you notice this parcel is represented in here twice. Some of these parcels, if they occur within 3 school districts, will be represented 3 times. So we can't go off of this percentage because it means something else. What we're wanting to do is we're wanting to figure out the percent of the area within the school district, and then we multiply that by the households to figure out how many households are actually within each school. So we need to recalculate our percentage to be what we want it to be. Okay. All right, so I'm going to close this. And so what we need to do is we need to get back the original area for this GeoID so that we can just kind of do what I did with the calculator, is divide this area by the original area to get the percentage of the original area. So I'm going to clear this, bring back the whole table. All right. And so we have our table here. And I'm going to do a join. And we're going to join our block group information, because remember we did that area calculation, so we have it. And we have our unique field of this GeoID. GeoID. GeoID, okay. And so now we have the original area over here. In your case, it's going to be this area cam. And so we can update this percentage column, which is wrong. It's just going to confuse the heck out of us with the percent that we really want. So the percent that we really want is going to be this area here, or you could use this area. You can see that they're exactly the same, divided by the original area okay. We don't want to multiply it by 100 because we actually want it to be a percent, so we want 75% to be 0.75. So for when we go do the next calculation. So hit OK. All right, remove. Okay, so now we have our percentage, and we can see we have a whole bunch that are 1. That means that these were 100% within a single high school. Now we need to add on the number of households. So I'm going to add a field to this database. We're going to call it household with kids. And it's going to be a long. We're actually going to join back the table we just removed because we need to grab the household with kids information. Okay. Find the household with kids information. Here it is. Remove the join. Okay. All right, so if this is 1-1, then yes, all 327 of these households with kids belong in this Bartlett school. I can't remember if I've showed you in other classes, but you can do a relate so that you can now visually inspect if what's happening is correct. So let's set up a relate where we can look and say, okay, I want to see where this one is to make sure that it actually is 100% within Bartlett High. So you can go up to your relates, add a relate, and we want to relate it back to our spatial block group information. And we want to relate it with that GeoID. Okay, everything else should be good. All right, and so let's see where this GeoID actually occurs. So we have this one selected. We can go up to relate data and relate it back to the block group. Okay, so this one actually occurs right here. And I'm going to turn off these block group labels because now they're annoying. And yes, it 100% is within the Bartlett school district. So let's go back to, let's find some of these other ones. Let's see, let's sort by GeoID. Okay. This one is kind of a funky one. This one is going to be a little weird because it looks like it potentially falls on the edge, given that it's in so many. Yeah, this is one where it's just kind of, this is just going to be noise in our data. You know, it's a little bit of a problem with the erase. But the fact is that when we multiply this, it's going to be not too many children. So that will be okay. Looking at some of the other ones, scroll down in here. How about this one here? This one says that it's divided about 56% in Diamond and 35% in West. I'll just kind of take a look. Huh. And it's this big census area, census block over here. Okay. All right. So I mean, there is some cleanup that we can do along the edges. It does create some issues. The fact that you have JBear in here too complicates things a little. But okay. So now we have our kids and we have the percent. So now we need to make a field that represents the updated kids and the updated households with kids, because the whole point in doing this is that you need to divide up the kids, the households, based on the percentage. So let's add a field. We'll try to add a field. Clear here. I'm not sure why it's not letting me add a field. Now it is. So we'll call it household update, and we'll leave it alone because you can't really have a half of a child. Decimal points would not be very useful in this case. All right, so we're going to use the field calculator, and we're going to multiply the household with kids by the percent area in which that census block occurs. So household with kids times percentage. Okay, so now this is our updated, distribution of the households to the different high schools based on the percentage of that census block that occurs within the high school. So now we need to add up our total households for each high school. So summarize. And we're going to add up the updated household with kids. Okay. So based on this is how many households with kids are assigned to each of these schools. So let's go back to our original high school funds table. Open that. And let's add two fields. One is called households. And then ones will be funds per household. Funds. Okay, this one can be a long, or sorry, double. Save. C. Okay, so let's do a join. We'll use the statistics that we just did. And the join is going to be our name. We're going to join and get in here the number of households. And we can remove the join. Okay. All right, for the next is to figure out how much funds per household would we have to pay in order to, achieve the same level of support that we got from property taxes. So we'll use the field calculator. And it's going to be sum of ASD divided by households. And of course there's a null, so it gives us this error. So you would have to pay approximately this much if you were a household within the Bartlett High School, so $5,300 and some dollars. I live within West. Ooh, I would not be happy with this policy decision. Yeah, nearly $18,000 in taxes. No, I don't think I could afford that. So I would veto down this policy decision if it was me. But yeah, this is an example, rather complex, of trying to figure out, okay, if we relied only on the household, and you got to figure out how to divide up the households so they fall within, your borders that don't align with the ACS data, how you do that, and then, distributing the money. So I believe that is all for this exercise. You know, you can comment on what do you think of this policy. I kind of gave my feedback. But yeah, like I said, it's a very complicated type of GIS exercise to go through. And I think it really stresses paying attention to your data and making sure you think what it's doing what it's doing. Because I myself actually got tripped up when I first did this tabulate intersect. I was like, oh great, I have the percentage right here and I could just use this and multiply. And then I was looking at it and like, wait, these aren't adding up to 100% for each of these block IDs, you know, the geo IDs. And then I realized, nope, I've got to figure out the percentage on my own. But anyway, I hope you enjoy this exercise and find it interesting.